Okay, so let's start the last question of this October 2023 paper. Number 10. This is from binomial expansion. So it is mixed with binomial expansion and series. Yeah. Part B is from sequence and series. Part 2. Let's see. Part 1. Find in ascending powers of x the second, third, fifth terms of the binomial expansion of 3 plus twice of x for 6. Okay, so we need to find out the second, third, and the fifth term for part 1a. We need the second term, right? So for the second term, we know that what's the expansion? 6 choose r would be what for the second term? First term it's 0. For the second term it will be 1. Right? So 3 plus twice of x. Okay. Okay. So second term. For the first term, it's 6 choose 1. Sorry, it's 6 choose 0. So for the second term, it will be 6 choose 1. 6 choose 1, then times. In the first term, they said in the ascending powers of, right? That means in the first term, the power of x 0, right? So here, the power of x would be 1. So the first term, the power of 3 was maximum, 3 to the power 6. Now in the second term, it will be 3 to the power 5 times twice of x. That's it. So 3 to the power 5 times 2 times 6. This is 2916x. That's the second term. Then they asked for the third term. The third term would be 6 choose 2, 3 to the power 4 twice of x whole squared. So what you would get 4 times 3 to the power 4 times 6 choose 2. This is 4860 x squared. And at last, the fifth term. Okay. For the third term, it's 6 choose 2. So for the fifth term, it will be 6 choose 4 times. For the fifth term, the power would be what? The power of 3 would be just 3, right? Fifth term, in the third term, we got 3 to the power 4. In the fourth term, it will be 3 to the power 3. Yeah, in the fifth term, it will be 3 squared times, yeah, twice of x to the power 4. Yeah, what would be the value? So 3 squared times 2 to the power 4 times 6 choose 4, which is 2160 x to the power 4. That's it. For a particular value of x, these three terms form consecutive terms in a geometric series. Find this value of x. Okay. For a geometric series, there should be a common ratio. That means, so what we can write, the fifth term, 2160 x to the power 4 over the third term, so that means 4860 x squared would be equal to the ratio of the third and the first term. So 2916x. Simplify this one. Get 4 over 9 x squared equals to 4860 over 2916. This is 5 over 3 x. So multiply both sides by 9. You get 4x squared equals to 15x. So 4x squared negative 15x equals to 0. So now you can take x common from there. 4x negative 15 equals 0. So either x would be 0, it's not acceptable. So you'll get x equals to 15 over 4. Because if x is 0, then there would no sequence exist. So the value for x is 15 over 4. Okay. For part 2, in a different geometric series, the first term is sine squared theta. Common ratio is 2 cos theta. The sum up to infinity is 8 over 5. Okay, show that this equation. Okay, fine. So the first term is given, the common ratio is given, the sum to infinity is also given. Okay. So for part 2a, sum up to infinity. What's the formula for sum up to infinity? This is a over 1 minus r. Okay. So what's the first term? Sine squared theta. So sine squared theta over 1 minus the common ratio, 2 cos theta. 2 cos theta equals to 8 over 3. Yeah, 8 over 5. Sorry. This is 8 over 5. So now cross multiply. You'll get 5 sine squared theta equals to what? 8 minus 16 cos theta. Okay. Now the question wanted all of the trigonometric ratios in terms of cos theta. So convert all of them to cos theta. So sine squared theta can be written as 1 minus cos squared theta equals to 8 minus 16 cos theta. So you'll get 5 minus 5 cos squared theta equals to 8 minus 16 theta. Now take all of the terms in the same side. So you'll get 5 cos squared theta minus 16 cos theta plus 8 minus 5. This is plus 3 equals 0. That's it. Okay, next. For part B, hence. That means you need to use this equation. Find the exact value of the second term in the sequence, in the series. Okay. So let's find out the value for cos theta to figure out the common ratio. For part B, what would be the value for cos theta? A quadratic equation, so minus b plus minus b squared is 16 squared minus 4 times 5 times 3. This is 196. So square root of 196 is 14 over twice of a is 10. So we'll get cos theta goes to 16 plus 14. This is 30 over 10. This is either 3, which is not acceptable since we know that the maximum value for cos theta is what? 1. So cos theta equals to what? 2 over 10, which is 1 over 5. So this is acceptable. So the value for cos theta we found. This is 1 over 5. So the common ratio R equals to 2 cos theta. That means this is 2 over 5. Okay, we got the common ratio. Now the first term and okay, they wanted the second term, so we need the first term and then multiply it by R to get the second term. First term is sine square theta, so sine square theta A is equals to sine square theta. So sine square theta is equals to what? 1 minus cos squared theta. This is 1 minus 1 over 25. So this would be 24 over 25. So we got the first term. So second term would be just what? AR. So 24 over 25 times the common ratio. This is 2 over 5. So we'll get the second term is 48 over 125. This is the second term. Understand? Okay, that's it.